Welcome back, students. As I promised in my last class that I'm going to show you the relation between the three terms for whom we received the definition last time. Okay, so we're going to go with the relation between them one by one. So first, let us see the relation between specific conductance or conductivity kappa and molar conductance lambda m, and that is capital lambda m. Okay, so if you see the relation between them, what you get out here is lambda m is equals to kappa into 1000 by c. The relation which you get is kappa lambda m is equals to kappa into 1000 by c. Now this means specific conductance or conductivity. Lambda m means molar conductance or molar conductivity, and this c, which is unique out here, this c stands for concentration in molarity. Okay, this C stands for concentration, and the unit of that concentration is molarity. The symbol is capital M. Okay, and 1000 is a number out here. So the relation is kappa, lambda m is equals to kappa into 1000 by C. So the formula is very simple. So students, if you want, you can easily remember those formula. Done? Now here we are going to see the unit of lambda m. If you remember in my last class, I have already said you the unit of kappa is ohm inverse centimeter inverse. Okay, now let us see the unit for the rest for lambda m. So I'm going to show you the unit for lambda m here. Kappa unit is ohm inverse centimeter inverse. Kappa unit is ohm inverse centimeter inverse. 1000 numbers, no need to write up the unit. And concentration unit is molarity, capital M, which also means mole liter inverse. So do remember, molarity also means mole liter inverse. So I place the unit of kappa out here and place the unit of C out here. What I have not put out here is 1000. Done? Now let us see how that 1000 has come. So ohm inverse is ohm inverse, centimeter inverse is centimeter inverse, mole is mole. So when liter inverse goes up, becomes liter. If liter inverse goes up, becomes liter, isn't it? So ohm inverse is ohm inverse, centimeter inverse is centimeter inverse, denominator is mole, so it is mole. And students, this liter means actually 1 liter, okay? And do remember, 1 liter is equivalent to 1000 ml. 1 liter means 1000 ml. And this is how this 1000 has arrived here. This 1000 came by this way, converting liter to ml. So this ohm inverse I am keeping as it is, centimeter inverse I am keeping as it is, mole I am keeping as it is. Now 1000 is a number, no need to write. But do remember, 1000 is a number, no need to write. ml and centimeter cube means same. So I am just replacing ml with centimeter cube. ml with whom? Centimeter cube. Done? Now this ohm inverse is here. Now let us solve these two. So centimeter cube minus 1. Centimeter cube minus 1 will give you centimeter square. So ohm inverse is here. If you subtract these two, you get centimeter square. Ohm inverse, if you subtract these two, you get centimeter square. If mole goes up, become mole inverse. If mole goes up, become mole inverse. And this becomes the unit of molar conductance, that is lambda m. But as I have already said you, ohm inverse can be replaced with omega inverse. It can be even replaced with mho, or it can be even replaced with Siemens. Others part is same, centimeter square mole inverse, centimeter square mole inverse, centimeter square mole inverse, centimeter mole inverse is same. So I have just replaced ohm inverse with omega inverse with mho and Siemens. So ohm inverse, omega inverse, mho and Siemens means same. And these are not the different unit, but they are the same unit. They all are the same unit of molar conductance. So you can write any unit in exam. You can write it as ohm inverse centimeter square mole inverse. You can write omega inverse centimeter square mole inverse. You can write mho centimeter square mole inverse, or Siemens centimeter square mole inverse. So students, in this lesson so far, what you have to remember, that the relation between lambda m and kappa is lambda m is equals to kappa into 1000 by C, where C is the concentration in molarity, capital M, and the unit of lambda m will come at the end, ohm inverse centimeter square mole inverse, or you can say omega inverse centimeter square mole inverse, or you can say mho centimeter inverse mole inverse, or Siemens centimeter square mole inverse. So remember the relation and the unit of lambda m from this part. Okay. Now we go to the second part. The relation between specific conductance, again kappa, and equivalent conductance lambda EQ, that is capital lambda EQ. Again, the relation is coming similar as above. If you see in the above case also, what we got is lambda m is equals to kappa into 1000 by C. Here also, whether you are finding the relation between lambda m and kappa or lambda EQ and kappa, you are getting the same kind of relation. So here also you are getting is your lambda EQ into kappa into 1000 by C. So here is M, but here is EQ. Molar conductance, equivalent conductance, but the right hand side is same. So here also, now let us see what does this means. Specific conductance, equivalent conductance, and here C means concentration in normality. Here C means concentration in molarity, whereas here C stands for concentration in normality, represented by the symbol capital N. And that's the difference. And if you go with the same kind of derivation, the unit of lambda EQ will come like this at the end. You just have to replace mole with equivalent, that is EQ. So you just, in place of mole, you write EQ, 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 EQ. So at the end, EQ inverse will come. Rest whole portion will be same as the way I derived earlier. The same will be for this. You just have to replace mole. You wrote C as mole liter inverse. Here this C should be written as EQ liter inverse. And if you derive it, you get this unit. So you can see over here. Ohm inverse is ohm inverse, centimeter square is same. So when it is lambda m, lambda m, so we write here mole inverse. But when it is lambda EQ, instead of mole inverse, we write EQ inverse. So here ohm inverse can be replaced with omega inverse, which can be replaced with mho, which can be replaced with Siemens, just like above. Okay, and if you see the difference in the unit, ohm inverse centimeter square, omega inverse centimeter square, mho centimeter square, Siemens centimeter square is same. Difference is lambda m, mole inverse, mole inverse, mole inverse, mole inverse will come. Lambda EQ, EQ inverse, EQ inverse, EQ inverse, EQ inverse will come, means equivalent inverse will come. So basically formula is quite same, and even the units are same. In lambda m, at the end you have to write mole inverse, whereas in lambda EQ you have to write EQ at the end of the unit. Done? Now out here a question arises, that is, so this is C in molarity, this is C in normality. How to remember? And this is the formula given in the book, which I want to change a bit. Now I'll write C suffix capital N, C suffix capital N. Now it makes a clear sense. Earlier when I wrote CC, there was a confusion. Now I'm writing C suffix capital N, C suffix capital N. Now there is no confusion at all. Now this means concentration in molarity, this means concentration in normality. So instead of C, you can write here Cm in the suffix capital N, and here Cn, that is concentration in normality. Okay, but do remember students, in your book it's written only C, but I'm writing it by myself for your convenience as Cm and Cn. So this becomes the formula for specific conductance and molar conductance, and this becomes for the specific conductance and equivalent conductance. And do remember they are the soulmate. Okay, this is your molarity, molecular weight, normality, equivalent weight. So they are made for each other. Okay, just like when you say Romeo, we say Juliet, isn't it? Similarly, this is molarity is linked with molecular weight, and normality is related with equivalent weight. So when I say next time normality, oh, sorry, it's talking about equivalent weight. You have to think that way. When I say molarity, oh, sorry, it's thinking about molecular weight. You have to remember that. Okay, so the relation is quite similar, students. Hope so you all understood. So if you want, you can take the screenshot of this. Afterwards you can copy. Okay, so remember the relation and the units for both. Now we will see the third one, and that is the relation between lambda m and your lambda EQ. Now we're going to see the relation is between lambda m and lambda EQ. Okay, students, now please be careful about the relation between these two. Done? So now let us see the relation between these two. Now students, we are going to see the relation between lambda m and lambda EQ. Done? So to see this relation, so you can see out here, students, what I have written here is Relation between molar conductance and equivalent conductance is lambda m is equal to z into lambda eq. This is molar conductance, this is equivalent conductance. So what is unique out here is z. What is this z out here mean zebra? No. This z out here in this relation means total positive or negative charge. So the total positive or negative charge is referred as z out here. Okay. So what does this z mean? Is the total positive or negative charge, students. So that means lambda m and lambda eq differ by z. So z means total positive or negative charge. So let us see how to find z first then. You can see here one compound I have given here is sodium chloride, which is a salt. Sodium chloride is a salt. And when you break it, this is your sodium, this is your chlorine. Okay. You all know the valency of sodium is +1 and chlorine is -1. And how many sodium is here? 1. How many chlorine is here? 1. So to multiply these two, 2 ones are 1 ones are 1 plus 1 ones are 1 minus 1 plus 1 minus 1 ones are 1 plus 1 ones are 1 minus. Total positive charge is 1, total negative charge is also 1. Therefore the z value will be 1. So if you put here z value as 1, then lambda m and lambda eq will be equal. If you put here z as 1, z1 into lambda eq is lambda eq. So for NaCl, lambda m and lambda eq will be equal. Now let us go with the next. You can see calcium, I have written here, this is calcium chloride, so chlorine is here. You can see 2 is given. What is 2? Chlorine is 2, so write here 2 as chlorine. Done? Now this 2 is the valency of calcium, and the calcium valency is +2 because this 2 indicates the valency of calcium. And what is here? 1. That is the valency of chlorine, so we write here -1. So now how many calcium you see? 1. And how many chlorine you see? 2. Now let us multiply the charge. 2 ones are 2 plus, 2 ones are 2 minus. So 2 plus 2 minus means charge is 2. So put here 2. So here you have to replace with 2. So for calcium chloride, lambda m is equals to 2 into lambda eq. I am replacing z with what? 2. This is how we find the z. Let us go for this, students. You can see aluminum sulfate is there. So I am writing the aluminum and sulfate. How many aluminium you see? 2. How many sulfate you see? 3. 2 aluminium I have written here. 2 sulfate I have written here. Now this 3 is the valency of aluminium. So write here +3. And this 2 is the valency of sulfate. So we write here -2. Now if you multiply these two, you get 3 2s are 6 plus 6. 3 2s are -6. So +6 -6 means z value will be 6. And if you put here z as 6, so what will be the relation between lambda m and lambda eq for aluminum sulfate? Lambda m is equal to 6 into lambda eq. So you all understood? Now we go to the sodium sulfate. Okay. Now next we go with is what? Sodium sulfate. Now you can see here is 2 sodium. So write here 2 sodium and sulfate is 1. Here was 3 sulfate. So I wrote 3 sulfate. But here is 1. So we write 1. Sodium valency is +1. I think every one of you know. And sulfate is how much? -2. Now multiply again. 2 ones are 2 plus, 2 ones are 2 minus. So 2 plus 2 minus means z is 2. So put here 2. Therefore the relation for lambda m and lambda eq for sodium sulfate will be lambda m is equals to 2 into lambda eq. So let us go for hydrogen chloride. You know that there is H and here is Cl, so I wrote it separately. Hydrogen valency is +1, chlorine is -1. So how many hydrogen is here? 1. And how many chlorine is here? 1. So 1 ones are 1 plus, 1 ones are 1 minus. So z value is 1. So put here 1. So for HCl, lambda m and lambda eq will be equal. Now here, sodium hydroxide, Na is 1, OH is 1. And the valency of sodium is +1, hydroxide is -1, as you all know. So 1 ones are 1 plus, 1 ones are 1 minus. So z value is again 1. So put here 1. So for NaOH also, lambda m and lambda eq will be equal. Now for sulfuric acid, you can see hydrogen I wrote, sulfate I wrote here. How many hydrogen you see? 2 of them. And sulfate, how many is here? 1 sulfate. SO4 means 1 sulfate. Now hydrogen valency is +1, as you all know. Sulfate is -2. So if you multiply these two, you get +2. And these two, if you multiply, you get -2. So +2 -2 means Z value is 2. So for sulfuric acid, if you have to put 2 out here in place of Z, then the relation becomes lambda m is equal to 2 into lambda eq. Hope so you all understood the formulas involved and how to find the Z. So likewise you can find the Z for rest other compounds also if it is asked. Okay, now let us see what is the advantage if you know all of this. And one thing you have to remember here, this is your what? Acid, hydrochloric acid, and since it produces how many H? Only one H it produces, therefore it is a monobasic acid. Okay, monobasic acid. Why we call HCl as monobasic acid? Because it produces one H plus ion. And what is the definition? These are those acids whose basicity is 1, means number of H is 1. And this NaOH is a base, it produces one OH minus, so those are called monoacidic base. Means base whose acidity is 1. Acidity means number of OH, 1, so mono. Basicity means number of H, 1, so mono. So acid whose basicity is 1 means if they dissociate they produce only one H. Okay. Base whose acidity is 1 means the one who breaks to produce how many OH? 1. And this is the salt in which the valency of both is 1. Okay. So let us do out here, students. Please be focused out here now. So for monobasic acid, for whom monobasic acid having basicity 1, for monoacidic base having 1 OH, or salt whose valency is what? 1. So monoacidic base means monobasic acid means whose basicity is 1. Monoacidic base means whose acidity is 1, and salt whose valency is 1. Basicity means number of H plus, acidity means number of OH minus. Okay, and salt whose valency is 1 in case of sodium chloride. For all of this, Z will come 1, isn't it? You can see here. For salt having valency 1, Z is coming 1. For monobasic acid, Z is coming 1. For monoacidic base also, Z is coming 1. So for all of them, Z always comes how much? 1. So when Z comes 1, that time what will happen? These two becomes equal. When Z comes 1, put here 1, lambda M and lambda EQ becomes what? Equal. That means molar conductance and equivalent conductance become equal. So for whom molar conductance and equivalent conductance is equal? For whom whose total charge is 1. And who will have total charge 1? Monobasic acid, monoacidic base and salt valency 1 will have Z value 1. And if the Z value comes 1, lambda M and lambda M will be equal. And as I said earlier, lambda M is molecular weight. Molecular weight is related with what? Molarity. And lambda EQ means equivalent weight. So it is related with what? Normality. It is related with whom? Normality. So do remember, students, for monobasic acid, for monoacidic base and salt valency 1, Z will come 1. For that case, molar conductance and equivalent conductance become equal. And if these two becomes equal, molecular weight, molarity, equivalent weight, normality also becomes equal. Clear? So you should not forget this relation. And molecular weight came from where? The molarity came from where? Molecular weight. And normality came from where? Equivalent weight. So this also becomes equal. So for monobasic acid means whose basicity is 1, the acid which will give you only 1 H plus. Monoacidic base means the base which will give you only 1 OH. And salt whose valency is 1. For all of them, Z is 1. So molar conductance and equivalent conductance will be equal. So if molar conductance and equivalent conductance is equal, so molarity and normality will also be equal. And if normality molarity is equal, so molarity means molecular weight, normality means equivalent weight will be also equal for such compounds. And you should not forget this relationship, students. Suppose if I give you one objective question here like this, lambda M for HCl is equals to, suppose 36 ohm inverse centimeter square mole inverse. Okay, so therefore lambda EQ will be how much? Now you can see here is given HCl. For HCl, Z is 1. We have found out here. So since HCl 1, so lambda M and lambda EQ will be equal. So Therefore, the value will be same. Lambda M and lambda EQ will be equal. We have to find lambda EQ. It will be the same, 36 only. And unit will be ohm inverse centimeter square EQ inverse. Now look out here nicely. Pay attention here. M, so mole inverse. Now you have to find EQ, so it should be EQ inverse. Also, you understood this objective also, students. So if you want, you can take the screenshot of this. Okay. Now students, after this all, now we can go with the some conclusion. So what is that? I'll let you know. First take the screenshot of this. I hope you all have taken that. Okay, now we go with further, and the further is this. Now you have to remember the overall formulas which I have given you so far for the numerical problem. Okay, and the formulas are here. Formula which you have to remember. One is rho is equals to Ra1. I have said you earlier. Another one is the formula of cell constant, that is Rk. Resistance is kappa. Another formula for cell constant which I gave you was La. Rk into La. Now you have to remember the other formula is lambda m is equals to kappa into 1000 by cm. Another formula just while ago I gave you, lambda EQ is equals to kappa into 1000 by cm. Molecular weight, molarity, equivalent with normality. Okay, and number 6 formula which you have to remember is this one, lambda m is equals to z into lambda EQ. So for this 6 formula, if you remember, student, it will be easy for you all to do the numerical problems. Done. So by this I come to the end of the today's class. So I showed you the relation. Remember, even the units, do remember that also, and along with that you have to remember the formula. So in our next class we will be doing the numerical problems related to these all 6 formula. Thank you very much.